No idea.
No idea? All right, Mason, see if you know problem.
The amount of gasoline is dependent, and the amount of time is independent.
Right, so the longer you drive, the less gas you're going to have, right? So if you keep driving, so that would be correct. So the independent, okay, is time spent driving, or just time. I'm just going to leave it as that. Dependent is going to be the amount of gas left. So the amount of gas in the tank. All right, modeling situations, modeling real life situations. Cell phone plan costs $30 for each line. All right, does the situation represent a function? Typically, these are going to represent a function. Okay, I don't want you to overthink these and then just stop. So just put yes, and we'll explain why. Identify the independent and dependent variable. Independent, Lucas.
The number of cell phone lines.
Number of cell phone lines. Okay. Dependent is going to be cost. Okay, so independent, number of cell phone lines. What would make it not a function is if you could have, say, somebody has 3 cell phone lines and you could get 2 different prices for those. That would make it not a function. So right now, if you got 1 cell phone line, it's going to be 1 price. You can't get 2 different prices. So that would be something that makes it not a function. You can have a maximum of 4 lines on the plan. Find the domain and range. So the domain is not continuous. You can't have 1.5 lines. You can't have 1.2 lines. All we can have are 1, 2, 3, or 4 lines because it says a maximum of 4. Well, based upon the cost will be our range. What's the cost of 1 line? It's a $30 for each line, so the cost for 1 line is 30. So that's your range. The cost for a second line is 60, 90, 120. So take a look at how that works out. 18, look at that answer. It's gonna be, you got to watch that. So look at that answer for 18 because this case here, you can drive 6.4 miles. Okay, you can take a taxi for 3.8 miles. So it's going to be different than the number of cell phone lines. Okay, does the situation represent a function? Well, can somebody drive 10 miles and get 2 different prices? No. So it is going to be a function. Independent and dependent. Independent is going to be the number of miles traveled. Dependent is going to be the total cost. The domain, you can drive at most 20 miles. So the domain is technically, we could start at 0 is less than or equal to x is less than or equal to 20. All right, look at the range. How do you think we got those numbers? Or I got those numbers on the answer sheet. Okay, it says 2.8 is less than or equal to y. Is less than or equal to, Damien, what's it say for the last one?
72.8.
72.8. All right. Where do we get those? Okay. Ava, any ideas?
I'm not sure.
You're not sure? Diana? Just pulled them out of the air? Juan? All right, how to figure out, all right, if you drive 10 miles, tell me how to figure out the cost. According to the situation, if you drive 10, how do we figure out the cost?
$2.80 plus $3.50 times 10.
Cost will be $2.80 plus $3.50 times the number of miles. So if I drove 10 miles, $3.50 times 10 would be 35 plus $2.80 would be $37.80. That's what it costs. You automatically get charged $2.80, right? So here's the deal. Now nobody would ever do this, but according to the situation, this is how we got to list it. If you drove 0 miles, you still would have to pay $2.80. I'd have a serious problem with the cabbie. If I got in and got out and you charged me $2.80. But according to the situation, you have to. All right, where's this 72? What's the most, Zach? What's the most miles I can drive or go?
20 miles.
So what do I put in here? I got 280 plus 350 times 20. What's that going to equal? If I take 280 plus 350 times 20, That's gonna be 72.8. That's the most that, according to this situation, I'm gonna get charged. The least would be 280. The most would be 72.80. Okay? We have to use the less than or equal to because we can go anywhere between 0 and 20 miles. It's not gonna be like a whole number. It's not gonna stop at 1 mile or 2 miles or 3 miles. Okay? Go all the way. All right, so that's that one. Look on the front, check your answers, and let's go over any that we need to while he's passing out the notes for the day. All right, look at the front and look at your answers from the answer key. This is new stuff, so you kind of need to really make sure you're paying attention. You really need to do the homework so that you make your mistakes now and you can fix them. Making mistakes is okay. Not getting it 100% is okay. But then we got to fix it. And this is the time so that we can get back on track. All right, Addie, you're always good for some questions, which I like. You got any on the front?
I was really confused on number 6.
All right, number 6. When you have a line or a curve, this is where you have to use the less than or equal to. And actually, let me do 5 first, and then I'll do 6. If I got a set of points, I just need to list the individual values for the x and the y. So for the domain, I have a point of x equals 0, 1, 2, 3, 4, and 5. So my domain is 0, 1, 2, 3, 4, and 5. I list them individually because those are the points, the x values that it hits. What y values does that one hit? Okay, the y value it hits are right here because it hits there, there, and there, and right above it. So the y values in the range are 3 and 4. Okay, those are y values. If you got a line or curve, this is where you use less than or equal to. All right, Addie, look in there. What is the furthest point on the left? What is the x value, the furthest point on the left? You can look at your paper. It might be a little bit easier.
-3.
All right, that's exactly right. Right here, -3. So I go down here and I make a mark. What's the furthest point on the right?
3.
3. Does it hit everything in between? Does that graph cover everything in between?
Yeah.
All right, so now how do I write that as a compound inequality? Okay. What do you think, Addie? Do you know? Is this where you're stuck?
I think this is where I'm stuck. I have it from like the notes and like the answer key, but I don't necessarily understand it.
So it goes from -3 to 3. It's in between those values, right?
Yeah.
This is how you always start with your smallest number. -3 is less than or equal to x. That says those numbers are bigger than -3. But they're not bigger than what? They have to stop where at?
3.
3. So it has to be less than or equal to 3. So when you have that, for the domain, you find the x values. For the range, what is the smallest y value? -3, you said?
Yeah.
That would be the y value. That would be here. That's -3 on the y. Does it hit down there?
No.
No. What's the smallest y, lowest point?
-1.
-1 would be, -1 would be here. Does it hit there?
Yeah.
Here's what I see. This is the graph, right? I see it stopping right there and going back up.
0.
0. So that would be the lowest y value it hits right there. What's the highest y value it hits?
3.
3. It hits everything in between. So now, how do I write that as an inequality? Start with the smallest number, which you said was 0. It does hit at 0. So you'd say 0 is less than or equal to y is less than or equal to 3. Okay? Let me just go through 7 real quick. Maybe. Undo it. Maybe. There we go. So domain. Find your x values. This furthest point on the left is this point here. If I look up here, that's at -1. The furthest point on the right is right here and it hits everywhere in between. So it's -1 is less than or equal to x is less than or equal to 3. Range. The lowest point Lowest point. Okay, look at it. Ryan, what's the lowest point?
-1.
-1 is right here. Does it go below that?
Oh, negative.
Yeah, you look. -4 right there. That's -4. What's the highest? Zach, what's the highest?
8.
8. Does it hit everything in between, Zach?
Yes.
So we're going to go range. -4 is less than or equal to y, is less than or equal to x. 8. All right, we're going to keep hitting this stuff. Lucas.
Wouldn't it be -8? Because,
For here,
yeah,
what's the highest point? That's the highest point there, right?
it goes up by 2s on the Y.
So that'd be 2, 4, 6.
No, he's talking
But
about
like,
the negative.
and then,
He's talking about what?
The -4. It should be -8.
Oh, should this be -8? Oh, I see what you're saying. Yes, I agree with you. Sorry. I got you. Thank you. Yeah, because it's going by 2, so that would be -4. That would be -8. Thank you. All right. So, yes, fix that. All right, we're going to keep hitting this, like I said, because it's new. It's new. All right, on your notes for today, section 3.2. 2 key things. We're going to talk about 2 intercepts and then properties of functions. All right, intercepts. Okay, good picture here, good description there at the top. An x-intercept of a graph occurs, okay, where the graph intersects the x-axis. Okay, your x-axis is the horizontal axis. We call that the x-intercept. The y-intercept is where it hits the y-axis. Okay, nothing crazy. Okay, so that is our y-intercept. We need to identify that. Now, where the x-intercept hits, the y-axis, the y-coordinate is always 0 because it's on the axis. If the y-intercept, the x-axis, or the x-coordinate is always 0. Now, for the next one, it just says estimate. Estimate. Now, some of them you'll know by looking at it. You'll know exactly what it is. Other ones, there will be an estimate. All right, x-intercepts. First of all, how many are there as you look at that? Jeff, how many times does it hit the x-axis? Once. Okay, right there. Now we're going to have to estimate. Where does it look like it hits it at about, Jeff?
Like 1.5.
1.5. So negative. Now negative. Always put a 0 for the y-axis. I'm going to put -1.5, comma 0. Because their y-coordinate would be 0. Taryn, did you look at that? How many y-intercepts are there? What do you think? 2 or 1? All right, you're looking at this line, right? How many times does it hit the y-axis? I gotta make sure we know what we're looking for.
Think about naming it.
Oh, she's thinking about naming it? Oh, is that would be the point. But how many are there? There's only 1. Good. All right, now how would you name it? Basically, when you name it, what are the coordinates of that point? There you go. Done. That's all you got to do. 0, 2. So for that one, you have 1 x-intercept, 1 y-intercept. Okay, so we want to label those that way. All right, look at the second one. The second one's a little different. X-intercepts. Okay, now, as you look at those, Carly, how many x-intercepts? How many times does it graph hit the x-axis? 2. Hits them 2 times. It hits it 2 times. Now name those 2 points. What are those 2 points then, Carly? Flip your order around. You always put the x coordinate first. So instead of 0, 1, you're going to say 1, 0. So it's going to be 1, 0. And you said 3, 0. All right, good. Damien, how many times does it hit the y-axis? It only hits it once. Okay, and it's not ever going to hit it again just because of the way the lines are going. So what it would be, how would you name that one? Damien?
0, -3.
0, -3. Good. So you can have more than one x-intercept. You can have more than one y-intercept. It all depends on the graph. But this one, you're just looking at the graph. You're just saying, all right, it hits it here. Name it. All right, now on the back. Okay, we got 3 things going on. We got positive versus negative. We got increasing versus decreasing. And then we got end behavior. All right, positive. Positive are when you get positive y values back. Those are when it's above the x-axis. Okay? Negative is when it's below. So we can take this same graph and we can talk about it in 3 different ways. We can talk about where it's positive. Now, increasing. If you think about increasing, you read from left to right. Increasing is anything that's going up from left to right. Okay? That is increasing. Decreasing is anything that's going down from left to right. Like my bank account, decreasing. It's going down. All right? So that's decreasing. And the way they have it shown, this blue line is that you see it's going increasing, and then anytime it gets to a peak or a valley, it will change from increasing to decreasing or vice versa. It goes from increasing, now it's going down, and then it goes back up. End behavior. This is basically saying, now I like to order it the other way. I like to put the x first. As x gets bigger, what's happening to y? As x is going to positive infinities, we're plugging in bigger numbers. The y is going all the way up, right? So that means it's going to positive infinity. As we plug in negative numbers for x's, what's happening to the y's? It's going to negative infinity. So we're going to need to talk through these, I think, for the first couple. This is a little bit new. All right, look at this graph. Now I'm going to do some things on here because I can erase them. It's a little bit easier for me. Positive. Everything above the x-axis. So everything that is positive would be all of these points. And once it gets there, it's no longer positive. How would you describe all of those points? We got that little stinking 0 there. Not sure what they want us to do there. Okay? Because technically it's not positive. If you look right here, what is that y value, Zach? 0. All right, so we're going to have to break this apart. I'm not happy about it. But we'll do it. All right, how do you describe all the x values for that?
As an increase?
No, well, go ahead.
As a positive?
Yes, it's positive. But how would you describe those? What x values those would be? Any ideas? I think this is the hard part.
Negatives.
Okay, negatives. Good. That's pretty good. Now, how do we list that as an inequality?
X is greater than. Never mind. I don't know.
How you do the inequality for the? We want to write our answer to the inequality. How you do it for the negatives? X is less than what?
X.
You gotta give me a number. 0. X is less than 0. Those are all the numbers that are less than 0. Okay? Those are all the numbers that are less than 0. You agree? All the x values. Now, what? I got to figure out what color I want here. Okay, how about for all of these? Okay, now it goes negative after that. How would you describe the x values for those?
0 is less than x.
Keep going. Yes. But then it doesn't keep going forever.
And then x
Where's it end at? Just give me the number it ends at.
Ends at 3.
It ends at 3. So good. 0 is less than x is less than 3. We're not going to use equals. So you trapped it between 0 and 3. Good. Good.
So, less than or equal or again?
No, because equal to
It's
equals 0.
0, yeah.
So that all these are going to be just less than. All right, what about negative numbers? Gavin, does the graph go below the x-axis?
Yeah.
It does? Yes. Okay, now, this is where it goes below the x-axis, right? And it keeps going because it has that arrow on. So basically, every x value to the right will give me a negative number. How do you describe that as an inequality? Any ideas?
X is greater than negative. Wait,
What is the x value right here?
3.
3. X is greater than 3. X is greater than 3. All those numbers bigger than 3 give us that. All right, now I got to erase all this because now we got to restart over. Increasing versus decreasing. Okay, where's it going? Now this one might be good to kind of trace on your thing. Where is it increasing? Where's it going uphill at? Okay, Zach?
From 0, 0 up to 2, 4.
Right there?
Yep.
That is great. That is where it's increasing. That is where it's going uphill. Then after that and before it changes. How do you describe the x values for this? Ryan, any ideas? What's the smallest x value for where it's increasing?
0,
What's the biggest x value for where it stops?
2.
2. So this is what you do. Since it's trapped in between there. 0 is less than x is less than 2. That would be increasing. Okay. Is it decreasing anywhere? It is. Now, this is hard because you got to think about going from left to right. This is going downhill, right? This is decreasing till I get to that point there. Then it goes increasing, then back decreasing. How do I list those intervals where it's decreasing? There's 2 chunks where it's decreasing. What's the x values for this chunk? It's all the x values that direction. Lucas.
-1.
Negative 1 would be one of them. What about negative 2? Negative 3. How do I list all of them? Using inequality. Okay.
Is it X is less than 0?
X is less than 0 would work. Now, there's also another chunk. There's another chunk. How do I describe those x values for that chunk? It's the numbers that are bigger than what? Bigger than?
0.
No, 0 is right here. It doesn't start decreasing until we get up to here, which is what x value? 2. So x is less than 0 and x is greater than 2. Okay? That's where it's decreasing. All right, think about this. End behaviors. X goes to infinity. X is getting bigger. Where's the y going? Is it going down or is it going up?
Wait.
Down.
It's going down. So what do we put for that? We put down negative infinity. That means it's getting really small. So this is going down. As x goes to the left, as x is getting smaller, what happens to y? Is it going up or down? It's going up, which means it's going towards infinity. All right, once you get that down, let's take a look at this second one. All right, first of all, positive. Does it go above the x-axis? Do you get positive y values back? All right, now I want you to think, how would you label it? What is it? How would you label that area? And these are all like that. When we label these, we're labeling kind of all the x values right here. That's where it's positive. That whole piece. Any idea how you would label that? Okay, Austin?
One is, would it be one?
All right, one's involved, you're correct. Is that the smallest number? Do you have a biggest number?
One is the biggest positive.
Look where it's-
Oh, two, yeah.
Two's right here, but we keep going to where?
Three.
3. So it's trapped in between 1 and
Three.
3. So you do 1 is less than x is less than 3. Oh boy, negatives. What are we going to think for this one? All right, Lucas, let's see what you got for me. How many sections is it negative? How about I ask you that? 2, this section here. How would you describe that using like this is your x value and it's everything to that direction? How would you describe that as an inequality?
X is greater than 1.
Are these numbers bigger than 1 or less than 1?
Oh, less.
So x is less than 1. Good. Okay, now there's a second section right here. How would you describe those numbers, Lucas? Greater than what?
3.
3. So it's going to be these two sections. X is less than 1 and x is greater than 3. All right, now I'm going to get rid of this because that can kind of confuse for the increasing and decreasing. All right, increasing. Well, do you see anywhere, Maddie? Do you think is it increasing anywhere?
Yeah.
Okay. Let's see here. Is this increasing?
Yeah.
Okay, tell me when it stops increasing.
Stop.
Right to there. Okay. Now, do you know how to describe that as an inequality?
No.
What is that value? Think x value right there, and it would be all these x values over here, right?
X is less than 2.
X is less than 2. Now, is increasing,
That's
whoops. It's increasing starting here going to the right, correct? Or decreasing. So it'd be all those numbers. How do you describe those as inequality?
X is greater than 2.
X is greater than 2. All right, I think end behavior you're going to be most comfortable with, hopefully. What do you think's happening? As x goes to infinity, which means as x gets bigger and bigger, is y getting bigger or smaller? Or going up or down? If it's going down, it's getting smaller. So what do I put for my answer here? Mason, any ideas?
Negative infinity.
Good, negative infinity, very good. What about for x goes to negative infinity? Where's y going? Is it going up or down?
No, it's not.
It's going down, right? So this is going to be negative infinity again. Okay. All right, that's it for the notes. Use these notes. You're going to have to use these as a guide. Okay. There's a, and I got like those extra those extra copies.
I think yeah, I put ones in there.
Okay. Hey, there's 2 problems on the back as well. Hey, this is important.
I heard it. Oh, it's okay.
This unit is gonna make you fail. I'm already failing fast.
Yeah, we need 2 graphs.
This is your 4.
I did.
Yes, you did.
But not for the first 5 minutes.
Sorry, I was thinking. Fantastic. Man, that's the first time I've seen that stuff.
I know.
Give me some, but.
Have a good day, guys.
Okay. Thank you, Reese.